On the fundamental theorem of calculus part 2. This is a good one, really important one. Lots of free response questions on AP are asked based on this topic, especially when we get to the graphing part of it. So essentially what it is we're going to start talking about graphs that look a little different. Here's what I mean by it. We're used to functions like this, like f of x equals, I don't know, like x squared plus 2, something like that. That's a graph that's based on position. Okay, so we'd read that graph based on, okay, what's the height of this graph? We're going to talk about a slightly different graph now. A graph of g of x where it's the integral from a to x of f of t dt. So this is still a graph that's based on x. This is a function of x. Okay, we got these t's in here, and the reason we have these t's is because it's just it's a function of a graph. So this is really a graph on area. So this is a graph on area, and it's just a little different, and it freaks some people out, especially when we get to some of the questions, because some people are like, oh, it's just super easy, but they're answering it incorrectly. They're mixing up position and area. So if you ever see a graph that looks like this, they're telling you this is what the graph is. It's a graph on the area. Okay. So here is what the FTC Part 2 says. That if you take the derivative of this, so the derivative of a graph of area gives you f of x, which is the graph on position. So that's important to know as we kind of go through this. So I'm going to kind of go through some of the rules here. So if you're just straight up taking the derivative of an integral, remember it's got to be with respect to x, and x will be in one of your bounds. If that's the case, this is just going to equal f of x. Technically, you have to take the derivative of whatever the bound. So the derivative of x is 1, so it's really f of x times 1. It's really a chain rule. If you have it where x is on the bottom, all you have to do is flip it. So it becomes d over dx of from a to x of f of t dt. And when you do that, you flip it, it becomes negative. So this is going to be the same thing. It's going to be negative f of x, but I had to flip it because x is on the bottom. And here's the part where the chain rule really comes into play. The derivative of this is f of g of x times g prime of x. I know notation is getting a little confusing, but this is all you do, is you take your x bound, your function bound, and then you plug it into the function of t times whatever the derivative is of that function right here. So just do it right here. So the derivative of this integral from 1 to x of t squared, what we're going to do is we're going to plug the x into the t squared. So instead of t, it becomes x. So it's going to be x squared times, what's the derivative of x? It's just 1. So this is just equal to x squared. Okay. Same thing here. All we're going to do here, take the derivative of this integral, is we're just going to take our x squared and plug it into our cosine. I don't care about this bound. This bound is not going to affect anything. So I'm going to take my x squared and plug it in. So I'm going to get cosine of x squared times, what's the derivative of x squared? It's 2x. So just make this look nice and pretty. It's cosine, there's 2x cosine of x squared. Okay? Box this answer as well. So real quickly, see if you can do this one using these same rules. So you can press pause when you're ready, hit play. Okay, so all I'm going to do here is just plug the x to the third into there. So it's 1 over 1 plus x to the third times derivative is going to be 3x squared, which is going to give me 3x squared all over 1 plus x cubed. And this is all that we're doing. That's it. So that part is the easy part if you remember the chain rule. All right, if you forget the chain rule, that's the only mistake people make, is they forget about chain rule. So do not forget about the chain rule part of it. We got one more of these types of examples. Yeah, I guess this one could be rewritten and stuff like that, but we'll just go through it. So I'm going to take my sine and plug it in here. So I'm going to get cubed root of 1 plus sine squared of x times, what's the derivative of sine? Just cosine. And that's it. Actually, this one you really can't clean up. This one doesn't clean up at all. So this is it. And there you go. All right, now we're getting to the graphing part, which I kind of alluded to earlier. So we have the graph of the function f consists of a quarter circle. That's this part right here, just so we know it is a quarter circle. That'll come into play. And line segments. So it's quarter circle and all line segments. And g is the function of g of x equals integral from 0 to x to ft dt, which means that this is a graph of area. Okay? So just real quick, if you have a graph of area, so G is a graph of area. In this case, G prime would be a graph of position. G double prime would be a graph of slope. And G triple prime would be a graph of concavity. Well, I kind of ran out of it, but it's graph of concavity. Okay, so essentially everything just got shifted, if that makes sense. So as we kind of go through these questions here, like for instance, B is going to ask us for a relative maximum, and what we usually do is we find the derivative of it. So we're going to find the derivative of G, but we just need to know that the derivative of G is not slope, it's a graph of position, and we'll get to there when we get there, and exactly how all of this should be written and all that fun stuff. Okay. Okay, so let's go ahead and find g of 0, -1, 2, and 5. It's not so bad. So all we're going to do, so for g of 0, I'll do this in a different color. For g of 0, we're just going to plug in a 0 for x. So I'm going to go from 0 to 0, f of t dt. So I'm going to look at my graph and figure out my area from 0 to 0. Well, this is actually a property. From 0 to 0 is actually going to be 0. There's no area because there's no width. The width is 0. So that one's pretty simple. Not a big deal. G of -1, this is okay. I have to think about this one a little bit. So I'm going to go from 0 to -1 of f of t dt. So I have to find the area from 0 to -1. Now, I'm not a fan of going out of order, so I'm going to do just a little bit of work here to switch it. So I'm going to negate the integral so that I can switch it. And now I'm going to look for the area from -1 to 0. So here we go. So from -1 to 0, this is a triangle with a width of 1 and a length of 2. So it's going to be negative, and it's going to be 1/2 times 1 times 2, which is going to give me an answer of -1. I'm going to switch up colors that way, because I might have to overlap here a little bit. So g of 2, that's going to integrate from 0 to 2 of f of t dt. So now I'm just looking from 0 to 2, the area from 0 to 2, if it's a quarter circle. And it's got a radius of 2. So it's going to be a quarter circle. So it's 1/4 of pi r squared. In this case, it's going to be 2 squared. This is going to give me an answer of pi. And then g of 5. Yeah, I'll do it in blue as well. G of 5 is going to be integral from 0 to 5 of f of t dt. Okay, so I said that this is pi right here. I'll just write it right in there. Okay, so from here to here is pi. And then I'm going out to 5, so it's just right here. So we got to figure out this area of this guy right here. Well, this is really just a couple of triangles, it looks like here. And it's all below, so it's going to be negative. So this is going to be -1, that's -1, and this is -2. Am I right saying that? Can I count? Yeah, okay. Okay, so this is going to be pi minus 4. I'm just counting area from 0 to 5. And there you go. That's not so bad. It's usually the part everyone gets right, and then this is the part where we kind of start to fall off the rails a little bit. Okay. So find the values of x on the open interval from -1 to 5, where g has a relative maximum. Okay? So what I'm going to do here is I'm going to make just a little bit of a sign chart, and hopefully it will kind of answer some questions here. So if I want to see where g has a relative maximum, I have to make a graph about g prime. So g prime from -1 to 5. Now this is a graph of position. So when is the position 0? That's my critical point. So when is my position 0? It's 0 here at -1, but it's not my endpoint. And then I'm also going to have a 0 here at 2. Okay? From -1 to 2, again, this is a graph of position. Let's focus on that. This is a graph of position. Is my position positive or negative from -1 to 2? Well, it's up, so it's positive. And right here, from 2 to 5, it's below, so it's negative. So where do I have a relative maximum? I have relative maximum at, it just looks for x values, at x equals 2. All right? Why? Because G prime changes from positive to negative. And that problem just became so much simpler once I made that sign chart. Okay, we're going to fall into less bear traps. Now, it's totally possible for you to talk about f. Some people talk about f. They'll say instead of G prime, they'll talk about f. So I'm going to write down this answer in black, and I'll tell you if it's acceptable or not. So just an alternate answer. So x equals 2 because f changes from positive to negative. So having this work right here where I'm at right now for black, I actually cannot get the full points because I don't know anything about f. I need to tell the grader that I know what f is. So if I state over here that f is equal to G prime, then I can talk about f. Okay, if I do not state that f is equal to G prime, then I'm not good. So this answer, I'll kind of bubble it on the side with all of this work I have here. This is full points. It's acceptable, but you have to, again, relate f to G prime if you're going to talk about f in your justification. Okay, that's why I typically just stick with G prime, but sometimes you're kind of handcuffed and we can't talk about enough of this information. Okay, all right, so here we go. Let's find the absolute minimum of G on -1 to 5 in the value of x at which it occurs. So we're going to find the minimum value and the x value as well. So this is going to be candidates test, which candidates test means I need to plug in my endpoints and my critical points. So I have endpoints of -1 and 5, and I have a critical point of 2. And I need to plug these into G. Now what's really nice is, and this is how most responses are with this type of question, is I already found these values. I already said that G of -1 is -1. It's up here. I already said that G of 5 is pi minus 4, which we'll talk about what that value is. And we know that G of 2 is already pi. Okay? So you need to state all these values in your critical points. Even though x equals 2 is a relative max, I do need to use that in the candidates test, or I need to explain why I need to eliminate it from the candidates test, if that makes sense. So you do need to mention 2 either as showing it as a value or showing why you're disqualifying it. So if I'm looking right here, what's the smallest value? Well, what if I don't know what pi minus 4 is? Well, pi is like 3.14. So if I take 3.14 and I subtract from 4, is that smaller than -1? No, it's like -0.8 something. Okay, so my absolute min value is -1. This occurs at x equals 1. All right, and justify my answer. It's all right here. I used everything I needed, and I'm good to go right there. Since I use this chart, that's my explanation. That's my justification. It's a mathematical explanation. I'm good to go. Okay, I use my endpoints, I use my critical points, or at least I talk about my critical points. And then let's find where the x coordinate on each point of inflection on the graph. So we need to find point of inflection. And so point of inflection would be G double prime. So I need to make a sign chart for G double prime. And again, this is from -1 to 5. Coming back up here. G double prime is the graph of slope, which means that I want increasing and decreasing values. This is going to help me find out if I have a point of inflection. So when do I change from increasing, decreasing, or vice versa? So, well, here at 0, before 0, I'm increasing. After 0, I'm decreasing until I get here to 2, because both these slopes are undefined. So that's why to me, they're critical points. So they're possible points of inflection. So at 2, actually, we're still decreasing until we get to 3. And then from 3, we start to increase. So again, G double prime in this, because my original function is area, G double prime is rate of change. So is it increasing or decreasing or whatnot? Okay, so I'm just showing this work for you. So now I can tell where are my points of inflection. Well, they're at x equals 0 and x equals 3. Why? Because G double prime changes signs. And that's enough. We're good to go right there. All right. You could also talk about F. So I'll get my little marker here. So you can also talk about F. So if you have this answer in in black, so we have 0 and 3, because F prime changes from, and then my problem with this is you have to state specifically. So from increasing to decreasing and decreasing to increasing respectively. I don't know if I spelled that right. Respectively just means that we're in the same order, so we're good to go. So 0 was the increasing, decreasing, 3 was the decreasing to increasing. But again, we cannot get full credit here until we actually say F prime is equal to G double prime. So that's why I prefer the pink answer, but just giving you a heads up, you can answer it like this. Black is perfectly acceptable as this answer. You just need to make sure that you mention the F prime, G double prime. But again, I'm showing you, I like this answer better, shorter, sweeter, and that's what I'm all about. Okay, and that's it.